So welcome back to 2.3 Pre-Calc Part B, and we are continuing on to find zeros of a problem. So as we look at this next problem, they give you h of x here, and we also have the graph already shown, and what they're asking you to do is just sort of find h of -2 if you were asked to do this. Now, could you plug in -2 in for all these x's? Absolutely. I don't know how comfortable some of you are with plugging in -2 though. So as a reminder, you could do synthetic, and the remainder will give you what h of -2 is. So as I bring the 2 down and multiply, and add, and multiply, and add, and multiply, what you'll notice is you get -9 is your value for h of 2. H of -2. And if you look at your graph, you can actually see, because it's going down, you would find at h of -2. Let's just confirm at h of -1 right here. Should get 4. Well, you can confirm that by doing synthetic, to just changing colors so you're not confused. I'm going to run into the next problem as well. So 2 times -1, and add, multiply, and add, and multiply, and add. Look at that, we just confirmed that h of -1 is equal to 4. Let me pause right there, because from the graph, I'm jumping to the next question. There's clearly a 0 over here. Okay, remember, zeros are x-intercepts. Now, how can you identify that there's a 0 from these values that we just got? -9 and 4. So let's think about that for a second. So on our x-axis, we knew that when x was -2, it went down here to -9, and when x was -1, it went up to 4. Now, we've talked in Unit 1 about continuity, and all polynomials are continuous. Maybe I'll write that down over here. All polynomials are continuous. That means the lame explanation is once you put your pencil to the page, you can't lift it up. So what's the only way to get from that negative value to a positive value? Is it had to cross 0 somewhere in there. So the premise being, and we'll do this again in calculus, is that the only way for a continuous function to go from a negative to a positive, or vice versa, that's what we're going to investigate with the next one, is to cross 0 at some point. And that's a very, very important fact. It's actually called the intermediate value theorem. Intermediate value theorem. You don't need to know that this year. You will next year. But we call it IVT for short. And if that made perfect sense, then you should definitely take calculus. So same premise with the next one is looking from 0 to x equals 2, which goes off the graph again. Now, finding h of 0, I would not encourage you to use synthetic, because just plug in a bunch of zeros and you'll get 3. So that makes perfect sense. Now, doing 2, I would go ahead and do synthetic. -4 and 3. So go ahead and perform the operations here. So it's supposed to be 7. So h of 2 was supposed to equal 7. Well, this time we went from a positive to a positive. So when you look at the graph of that down here, is we went from a positive value to another positive value. Again, it is continuous, but does it have to cross the x-axis to get from here to up here? It does not have to. Now, if you look at this graph, clearly it does. You know, it goes down and it touches the x-axis. But does the same reasoning apply concerning a 0 in this one? No. And numerically, it's because we went from a positive to a positive. Do we have to cross the x-axis? Do we have to cross 0 to go from a positive to a positive? No. The only way we must hit a 0 is if we go from a negative to a positive or from a positive to a negative. So try to explain that in your own words or think about it. And don't be afraid to come ask me for a little bit more clarification or if you need just more examples. Let me actually pull up the answer key. So I'm not trying to inundate you with a lot of writing, but maybe go ahead and read this. Make sure it understands, that you understand. Okay, and notice that on this one there is a possibility of a 0 when it goes from a positive to a positive. Also notice he doesn't write it as a positive, he wrote it as greater than 0, but that is the same thing. So again, I felt like I could just share the answer key with you before doing more examples. So if they change signs, if we go from a positive to a negative or a negative to a positive, it is guaranteed to cross the x-axis. It is guaranteed to have a 0. But if they do not change signs, then it is not guaranteed, but it is possible. Because you could always dip down in that previous example to touch it like it did. But it's not guaranteed is the main thing there. All right, so go ahead, pause, and make sure you understand as I finish up our last examples. So we've been looking at a lot of graphs. Let's look at a table. Make sure you read the directions. I infamously forget about directions sometimes. So hold me accountable that we have a quartic function. So as a reminder, that's a clue that we should have 4 zeros. And if we don't have 4 zeros, then we should have some sort of multiplicity here. It has a negative root and 2 distinct positive roots. Yeah, I think that's pretty much everything you need to think about. So as we look at this problem, is there any other root specifically identified in the table? Now remember, a root is also called a 0 or a solution or an x-intercept. So remember, the x-intercept is when y equals 0. So that is definitely given to you in the problem, that x equals 1 is a root. Now this is sort of open to interpretation, but what we're trying to get you to think about in this problem is to the left of that value was a negative, to the right of that value was a negative, so we're just going to infer that it just touches the x-axis there. I've seen students in the past, they actually draw it out, that at x equals 1 you get 0, and at x equals 0 it's -3, and x equals 2 is -2. And they actually visualize that it just touches the x-axis there. Now, I definitely agree, because I had students in the past tell me, well, what if it goes above and then back down or something like that? And that there, you are right if you were thinking about that, but we're going to infer if you see a negative directly to the left and directly to the right that it just touches. Same thing with a positive. We are going to infer that. And there's more reasons to that as well. So when it just bounces or just touches the x-axis, that's our clue that that has a multiplicity of 2. So again, what's your reasoning for this? Is we have a negative to the left. I'll go ahead and write it sort of as the notation that we have. You don't have to write it this way. As x approaches 1 on the left side, we called it f of x is negative, and as x approaches 1 on the right side, that function is also negative, sorry. And that's your clue that it just bounces off the x-axis. I think that's the word I used. I think that's a good explanation. So now what about the other roots? Well, right now we're going to examine the negative root. Okay, now when we say the negative root, we're talking about x equals a negative number. So examine the negative values. What's special about here? I'm seeing a negative is changing to a positive. Now technically it's going from a positive to a negative. And again, I've seen students actually write out, at x is -4, it's all the way up here, and at x is -1, it's all the way down here. I don't know where it crosses the x-axis, but it has to cross the x-axis. So I shouldn't really write it like that. I should say between values for x would be between -4 and -1. Why? Because f of -4 is a positive, and f of -1 is a negative, and the only way to change from a positive to a negative is by crossing the x-axis. Now, if anybody wants to, because I already introduced it to you, if you write by the intermediate value theorem, IVT, I will give you full credit, because that is correct. And what about the distinct positive root? So again, we're looking at a positive value. We want to look for the same thing. Does it ever change from a positive to a negative, or a negative to a positive? Negative to a positive between what two x values? 3 and 5. Between 3 and 5. Now, when we get to calculus, I will be stricter about your explanation. There's certain things that we look for, but again, the main premise is saying that f of 3 was a negative and f of 5 was a positive. Okay. Like for instance, you should also mention that it's a continuous function. But right now we're only dealing with polynomials, so they're all continuous. So go ahead and pause this. Make sure that you're good before we move on. And actually, we should be ready to do the homework now. If anybody's curious, about what I look for so I'm done with the video. You have enough. But something I do want to mention is when I was grading these tests, I actually had to mark students incorrect when they gave their reasoning. So this is extra knowledge for anybody that's curious. You had to write it in the correct order. For instance, it makes perfect sense to write it this way. F of 3 is less than f of c, which is going to tell us that f of c equals 0 in the problem. That's what we're looking for. The roots are when the function equals 0 is less than f of 5. And then they would write therefore. This is our symbol for therefore if you haven't seen me write it yet. There's a value for c such that f of c equals 0 between 3 and 5. So this would be the correct way of writing this. The reason why I bring this to your attention is I had to mark students wrong before when they wrote this on their paper. Equals the root is less than f of -1. And you might be saying, well, what's wrong with this? Well, it's an incorrect mathematical statement. We're saying a positive is less than a 0, which is less than a negative. 0 is never greater than a positive number. So I had to mark students wrong with this, and they lost points on a very important test because they didn't write a mathematically true statement. So if that just made sense to you, then you are definitely on track to take calculus. If not, we will get you on track when we cross that bridge. So thank you for sticking with me if you were still watching the video, and you should be ready for the homework.